in previous diagram I have explained and I have taken only single ray, but here I am taking two rays and the object is placed at a different distances, right. So here I am taking the distance is infinity point. We don't know the particular distance, the object is placed at a infinity. Now the rays of the body is comes to and fall on the surface of the reflecting surface, and the incident ray is reflecting to the reflecting surface and reflected ray is passes through the principal focus. It is a principal focus point, the rays are passes through it. Then it is a center of curvature. Angle I and angle R. I means the angle of incidence, R means the angle of reflection, right. So it is a diagram A. Given mirror is Mn and points are D. You know the center of spherical mirror is called as pole point, and another point is reflecting point is, you can take give name is DE, right. Then again the second diagram, in first diagram the object is placed at infinity, right. The object placed at infinity, image obtained at a point of principal focus. Now again in second diagram, it is a diagram first, next second diagram, the object is placed, it is a concave mirror, the object is placed beyond C, right. Next the ray parallel to the principal axis, it is parallel to the principal axis, then falls to the surface of reflecting and turns back to the same with the different direction. It is a ray, principal focus, and another ray, that ray passes through center of curvature. Two rays are there, one ray is parallel to the principal axis, another ray passes through center of curvature, and it emerges to the same point, center of curvature. Both the rays, first ray and second ray, joins at one point. The object distance is AB and it is the image distance A dash B dash, right. So it is center of curvature point, it is a principal focus point, this point is principal focus, and MN pole point. Now the object placed at beyond C, right. It is a point C, this is the point C, and placed beyond C, the image obtained in between principal focus and center of curvature. Clear? In between principal focus and center of curvature, right. We got, when object is placed at infinity, the image distance is principal focus. When the object is placed beyond C, the image obtained in between principal focus and center of curvature. Next, third point, concave mirror, principal axis. Now it is a center of curvature, principal focus, pole point, opaque surface, mirror MN. Now the object placed at a distance at a point center of curvature. Now the object is placed at a point center of curvature. Ray, it is a ray, incident ray that passes through reflecting surface, and it is passes through principal focus. Now again another ray parallel to A, B, parallel to principal axis, it is passes through reflecting surface, is passes through again principal focus. Now object placed I will draw third diagram here. Concave mirror, principal axis, center of spherical mirror, mirror MN, center of curvature, principal focus. Now the object placed at C, it is a point C, the object placed at a point C, the distance is AB, the reflecting surface is travels through and passes through principal focus. Now again the second ray passes through principal focus, the second ray passes through principal focus, and it is reflected ray of the second ray parallel to the principal axis, parallel to the principal axis. The incident ray of the second ray passes through principal focus, and reflected ray of the second ray passes through the principal focus. Both the reflected ray are joined at one point. The distance is A dash B dash. Right. Now you can take here the object placed at point C, you know C means center of curvature, image obtained at same point, center of curvature. In first diagram, the object placed at infinity, the image obtained at F, principal focus. Next one, the object is placed at beyond C, the image is obtained at a in between center of curvature and principal focus. Next, in third diagram, the object placed at a point center of curvature, the image obtained at a same point center of curvature. Next, fourth diagram. Right. So these are the 3 points of the body of the given mirror. Now the fourth one is, it's a concave mirror, center of curvature, principal focus, now object. So here the object is placed in between, C and F. It is a point C, it is a point F. The object is placed here. It is a first ray. The first ray, it falls on a given reflecting surface and it refracted back to the same medium with a different direction, and it is passes through center of curvature. Then again it is a second ray, falls on the reflecting surface, returns back to the same medium, and reflecting surfaces passes through the reflecting surface passes through center of curvature. Center of curvature, the image obtained beyond C. It is center of curvature, image obtained beyond C. Right. See here, two rays. One ray is this one, another one is this one. The first ray is parallel to principal axis, and second ray is falls on the surface of the reflecting face, and the reflecting ray passes through center of curvature, and both the rays are joined at a point beyond C, so that the object placed at point in between C and F, the image obtained beyond C. Here object placed between C and F, image obtained at C. Right. Next, fifth one, it is a concave mirror, principal axis, pole point, center of curvature, then principal focus. Now we done, the object is placed at infinity, beyond C, at C, between C and F. Now object is placed at F. It is a F point. It is a first ray parallel to the principal axis, then it is passes through principal focus and principal focus, then again second ray, it is a second ray, then the reflecting surfaces passes through center of curvature. It is center of curvature. The image obtained at infinity point. Now the object placed at a point principal focus. It is a principal focus point. The object is placed here, right? But the image obtained with the different rays, so at a point of infinity. Now again object placed at F, principal focus, image obtained at infinity. So these are the object position and image position, right? So in first diagram you know that the object is placed at infinity, the image is obtained at a point F. In this diagram the object is placed F, it is vice versa to the first diagram, the image is obtained at a point of infinity. In first diagram the object is placed at infinity, image obtained at principal focus. In this diagram what we have discussed now, so in that diagram the object is placed F, the image is obtained at infinity. Next, in sixth diagram, only last point, only one possible to place the object in between pole point and principal focus. First we have kept the object at infinity, next beyond C, next at C, next between C and F, next at F, next final position is the object is placed between principal focus and, it is a principal focus, between principal focus and pole point, right? Now object is placed here, the rays travels, first rays travels in this direction and reflected rays moves in this direction. Next second ray goes in this direction, the reflecting rays travels in this direction, right? So again we can understand in those diagrams the object, right, the position of the object at infinity. In first diagram the position of the object at infinity, it is the position of the object at infinity, that is the first point. In second point, beyond C. In third diagram, at C. Fourth diagram, between C and F, right. In fifth diagram, at F. In sixth diagram, between F and P, right. In different position of the object, position of image is, position of image, at infinity point, the position of the image is at principal focus F. Beyond C point, between C and F. At C point, at C. Between C and F point, C means center of curvature, F means principal focus, understand. Then here the object is placed between C and F point, that the object is obtained beyond C. Next, at F point, the object is at infinity. Next, between F and P, behind the mirror, the object is obtained behind the mirror, right. We have to get the image another side of the mirror. Why? Because of the image, the object is very closer to the reflecting surface, so we cannot get the image at the same side. When the object is placed in between F and P or closer to the reflecting surface, the image is obtained another side of the given mirror, right. That is appears, diverge to appears point. So this is the image obtained side of the given mirror. Then again, the position of the image is behind the mirror, behind the mirror. So these are the different position of the image and object. Next, we can discuss some size. When the object is placed at point P, that the image size is very small. And once again, open your textbook and open the page of 163, 164. Then you can see the images of the different position of the concave mirrors. When the object is placed at infinity, the position of the image is at point F. The size of the image is very small, highly diminished, point sized. Then again, at beyond C, the size of the image is greater than the size of previous one. Then again, when the object is placed closer to the surface of the pole point, the size of the image is increases. So first one is very small, after that diminished, greater than the size of the at infinity point in beyond C. Then at C point, same size, the size of the image and size of objects are same. Then between C and F, that is enlarged. Then at F, the image is size of the image is highly enlarged. Between F and P, the size of the image is again enlarged, greater than the size of at F point. So these are the different positions and size of the image, size of the image. Then now again, in first diagram, position of the object is at infinity, image at F, then size, then nature of the image is, that is a real and inverted. It is a real and inverted. The object is obtained in reflection, but it is only for reflection. The object is obtained in the same side of the reflecting face, right. So that image is called as a real image, but that is inverted. This is in this direction, but image is here inverted, opposite direction. Same here also, inverted image and real image. Here also inverted image and real image, right. Inverted and real. In last one only we get in the last diagram, the image is virtual. Why? Because of why? that is the image obtained in another side. Why no? The image obtained in another side, so it is called as virtual image. Previous, virtual and erect, and the image obtained upper side of the principal axis. If it is lower side of the principal axis, means that is inverted. The image obtained another side of the mirror, so it is called as virtual image, and upper side of the mirror, upper side of the principal axis, so it is called as erect. So these are the difference between the different diagrams. At f, at infinity, beyond c, at f, between c and f, at f, and between f and p. So these are the explanation related to image formation by concave mirror for different positions of the object. Okay, clear? Thank you.